Hi, this is Matt at Keil Avionics. I am making a quick video describing a document and software tool chain. And a tool chain is like basically it's a system of where you uh, you could call it a food chain, but it basically it's a system where you document something and something else parses that document and produces a more manageable format. And another tool might parse that and do something else with it, and another tool might parse it and do something further with it. But a tool chain is a really important thing for reducing man hours on a project. You basically want to try to automate as many tasks as you possibly can so that you only have to write something down in one place, and then the change impact is automatically accounted for by this tool chain. Or you could throw bodies at it and have it a procedure or a process that requires a half a dozen people to maintain. So this is all about maintainability. And one of the things that I kind of clued in on, just in terms of aerospace software in general, is that there's a lot of moving parts and it's hard to maintain. So what we have here is we have source code for our U1713 adapter, and we're going into some new peer reviews with it. And I want to get this source code as strongly typed as I possibly can, meaning that uh, there, if there's any issues with it in terms of formatting and coding standards and stuff like that, it just pops out to me immediately, and we can go and update it because this is our one chance to do that for a while. Uh, but here we have like a regular code comment, and then here we have a comment that's for this header, so to speak, right? So this ADC register in it, and this is what it does. And the Doxygen is fairly ubiquitous in the civilian sector, what I would call like the non-aviation people. Like if you were going to buy a source code from or a library from a third party, typically they're already using Doxygen. So, and the Doxygen will produce a manual that is like the online help manual. So I'm going to kind of describe how that's worked right now. So a regular code comment might look like this, right? With a single asterisk, you get that code block, and Doxygen says throw another asterisk in there, and then we'll parse that. And this is just a test formatting that I have done. So I started with one of my function headers, and I kind of wrote a bunch of different commands in here. So we've got brief, we've got bullet points, we've got a new paragraph, we've got a note, we've got a C section, attention and warning. And when you download Doxygen, you basically just point it to your input files, and in this case, I'm pointing it to my source code for the U1713, and then I hit run, and it produces this log, and it takes just a minute or so, depending on how much code you have, and then you can click show HTML output, and it produces this website. Okay, so let me orientate myself here. All right, so it produces this website. Now, this website is I mean fantastic. You can go down through all your source code, all your modules, right? You can get information on structures. You and it gives you these great little call diagrams, for what each one of these things are doing. And it's just a great way to review your source code because it basically takes you from a softly typed environment, which is here, and puts you into a strongly typed environment here. I call it effectively, it's compiling your code comments. So if you don't have like an argument documented, you don't get it here. So it's a great way to say, hey, I missed commenting something, and you can go back and do it. Now, the FAA loves flat documents. If it doesn't print out flat, then the FAA really doesn't want to deal with you. So, DO-178 lays out these document formats that they're not particular. I mean, if you keep, I've looked at enough DO-178 data packages that when you start looking at the planning docs, you start looking at the quality assurance plans, a lot of that stuff is boilerplate, but it really starts to fall apart down at the design description, because the design description is the document that nobody really likes to do. There's not a real set format on it, and it's usability. I mean, I'll just straight be honest. It's more a document that documents what you did, not what you need to do. To me, I've never considered the design document like a requirements document. So you have software requirements that say the software shall do this, and you can write the software requirements before you ever write a single line of code. But once you get down into the software design, yeah, maybe on larger teams and larger projects, the software design document can serve as like that seminal document that you say you shall do this, and this shall be put in this data buffer, and it might describe the interactions between different software modules and stuff like that. But I usually do the software design document after the fact, and that's taboo, and I apologize. But it just is the way that it is. It's an iterative process. There's a lot of iterative concepts in D178, but the FAA expects a linear process. You basically, you make plans, you make requirements, you implement, and then you test. And there's not a lot of refactoring. And I'm sorry, the world is refactored all the time, and that's, you have to account for that. So maintainability in my mind is being able to refactor efficiently. And to do that, you have to write information down in one place, have a tool chain that disseminates it to all of its little cubbies where it needs to go. And then the change impact is very easy to figure out. So DO-178 says the design document has to do XYZ, things like a description of the software, input-output descriptions, data flow and control. Now, there's not a lot of data flow and control, my air quotes here, data flow and control in DO-178, but it's super important, especially for complex, what I would call complex software. That's not really a DO-254 thing per se, but some software without constraints can get very complex. You can have polymorphism, you can have inheritance, you can have dynamic memory allocation and garbage collection. You know what I mean? None of that stuff is desirable in safety critical applications, so you want to boil it down. Now, from the source code to Doxygen to a website that, let me go back to this one, to a website that documents the code, there's a lot of reusable pieces in here that we should be able to take and just drag and drop right into our software design document. I'm going to do that programmatically, but for now, we're going to do it manually. But if I go to, and it gives you a lot of really good formatting options. So AO1 initialize. If I come over here and I open this up here, there's my function AO1 initialize, and I can go to its documentation. You can see that. So here's some formatting, right, and a diagram, and it gives me attention, warning, note. That's what I have here in my source code comment. So how do I get this into a Word document, right? And it's easier than you think. Even though it's a headache, it's easier than you think. So I've tried a dozen different ways to get it out of Doxygen. So Doxygen has this latex, which is like a typesetting thing. I failed. I can't figure it out. Has a rich text format, has manual, a doc book, has a bunch of different ways to get outputs out of Doxygen. And I want to reuse that strongly typed output from Doxygen that created HTML in my Word documents. And there's just not a lot of good ways to convert it. And then even then, Doxygen, when you look at latex, and when I finally could get it working in rich text formatting, the formatting on the page was just not very good. And it didn't look as good as it did in a website. So if you didn't know there's a formatting called OpenXML, and if we had a Word document that is like this, so I'll open this document up here. This is a new document, right? That's all that's in this document. If you come over here and you change, so anything that has X on it is basically a zip file. So docx, xmls, xlsx, ppt for PowerPoint X, all these are just zip folders. Are you sure you want to change it? Yes. Now when I open this thing up and I go into here and I grab document.xml, I'm just going to come up out of this 1 second. And then I'm going to open, I like to use Ultra Edit. Ultra Edit's pretty good. Microsoft Visual Studio has a program called Code that's very good as well. I might switch to that. But for now, I have an Ultra Edit license. I'm just going to keep using it. So stand by while my machine thinks about this. It's still working. Making these videos really puts the crunch. Okay, so I think this is that XML right there. So it's reopening the last one. If I go to coding and then I tidy this up. Yeah, here we go. So we've got the body of the document, we've got the paragraph, we've got the run, we have the text, right? And these bookmarks. So that's basically that document. So you can if you know XML, you can programmatically create Word documents using something called OpenXML. So I'm going to close that out for a second. And OpenXML, go ahead and check it out. The schema for it is published, and then you can basically play with the formatting how you want it to look, and then go back and open that document.xml and reverse engineer that file. And that's how I did this. Now, what I did was I created a project that parses the Doxygen output, and it just builds the string that is the Word document. So I programmatically go through the HTML from the Doxygen, and I produce a document from that. So this is what I did last week. So, we've got a table row, we've got a table cell, we've got table cell properties, and then there's another table that goes down inside of that. So what it's going to do is it's going to parse Doxygen. Let me change this back to a doc, because it's going to overwrite this document right here. So now it's that document, and we'll open it up again. I'm still using Microsoft Office 2010. I refuse to buy 365. I'm a little bit of a hardliner, I think, sometimes. If I had a contract where they needed me to buy it, I would buy it, but just not right now. All right, so we got an empty document. I'm going to save that. And now I'm going to run my Doxygen parser. That's what I call it for now. So the tool chain is source code comments to Doxygen, Doxygen parser to document. And it's going to open up all of the HTML files, or in this case the XML files, and it's going to go down through them. There's not too many. I have a little time delay in there, so that's why it's running a little slow. Just gonna do the whole project. So this was written in C sharp. C sharp has got the .NET. I find that if you're writing programs for Windows, the .NET is a very important framework to use, and it's really terrific. But you could write OpenXML using Python. You could write OpenXML using any language you want, really. C sharp has some pretty good extensions that you can get on NuGet that help managing it very easy. So basically, you can just take a string that is your Word document and pass it in and create. I'll show you here. So I want a paragraph. You can just pass that string right in, and then boom, you have a paragraph, and then you can add that paragraph to your document, right? And that's how that works. So what I do is I format everything in the way that I want to see it in the HTML, and then I run my Doxygen parser, and then I get these tables. So these are all so this is the website right here. So let's go and compare these things. Okay. My website, stand by here for the Doxygen. There we go. So it's not easy to get this without this and everything like that, because if you even just tried to print this to PDF, it wouldn't get you there. To get this into a document where it fits on the page and can be presented. So what I did, I should make that yellow maybe. I don't know. I didn't like yellow for note. But what I did was I parsed this whole thing and produced a Word document that had, I wanted all my function calls. So here's all my function calls with the pictures, with the argument descriptions, and I wanted all my structures as well. So I just implemented the structures today. And I think between those two things, that's all I want for my SDD. And the next step is to basically take these tables, these snippets. So I made this tab out of a table. You can see that's a table cell right there, right? I'm going to make it so that the parser inserts all these where they go inside of my SDD document for DO178, so that I don't have to do all these by hand. And if I go and I change the source code, I can rerun this whole tool chain, and then it updates the software design document automatically. And to me, this is just tremendously valuable to have in a design document. Is cleanly formatted, strongly typed code comments. And after I have this working, I might make that a feature in Karma. So we trace high-level requirements to even MOPS and TSO requirements. We trace software requirements into the software design document, down to source code, to verification tests like unit tests and acceptance test procedures, to verification results, to peer reviews, to everything. We do all of our tracing using Karma. We wrote this application you don't have to, it's not DO178 centric, but we wrote this application that satisfies all the DO178 objectives. And it parses all the documents and shows you uplinks and downlinks, gives you trees, enables you to basically identify what documents are needed in a project file. And I think this parser, where it extracts Doxygen formatted source code comments, I might somehow get that into this as a feature, or maybe just include it as a utility off to the side. But if you're interested in Doxygen, give me a holler. It's a pretty terrific time-saving tool, and it makes things like structural coverage analysis and change impact and the V model for ARP 4754, those types of activities really easy. So that's all I got. Take it easy, everybody.